All right, guess what? Lesson 2, same outfit. I know, call me crazy. All right, so our title is called Function Rules. So today we're going to talk about those rules that yesterday we were talking about in our tables that they gave us. Some of them we had to come up with at the beginning. So we're going to talk a little bit about function rules. There's 2 vocabulary words you're going to need to know for this one. It's the arithmetic sequence and the geometric sequence. So go ahead and put those in your books, and then we're going to define them just a little bit so you have that. All right, arithmetic. Arithmetic is when you add or subtract the same number from the previous term. Don't get scared. We're going to go through this. So I'm just going to use symbols, add or subtract the same number to previous term. These are the ones that we're used to, counting by 2s, right? 2, 4, 6, 8. Counting by 3s, 3, 6, 9, 12. Or even counting backwards by 5s, 10, or I shouldn't start at 10, 20, 15, 10, 5, 0. We're subtracting the same number from the previous term, or we're adding the same number to the previous term. We can handle that. Geometric is multiplying. So I don't want to put an X there because we're learning about various. So we'll multiplying the same number to the previous term. So this would be when I multiply the previous number by 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and it keeps going. So we're taking the same number and we're multiplying it to the number before. That is a geometric pattern. So at the beginning, I'm just going to give you some patterns, and we're going to figure out what kind of pattern it is, and then we figure out the next 3 numbers. We've done this before. Nothing hard. Number 1. So if I give you the numbers 7, 14, 21, and 28. So those are our numbers. There's 3 things I need from you. I need to know what's the pattern. I need to know what kind of sequence it is. Those 2. And then I need to know next 3 numbers. I know I'm using a hashtag, but it's simpler. All right, so I'm trying to think. Okay, 7 to 14. Multiply by 2. 7 times 2 is 14. All right, let me try it to the next one. 14 times 2 is 28. Not going to work. All right, so I know I'm going up. So I know I either can add or I can multiply. So let me see. 7 times what number is 14? 7. Oh, I'm sorry. We just multiplied. Take that back. Let's try adding. So 7 plus what number will give me 14? 7 plus 7 is 14. So 14 plus 7 is 21. 7 plus 21 is 28. I think we're on to something. So our pattern is adding 7. So we can just use an addition sign in 7. All right, so my sequence, is this arithmetic or is this geometric? Well, arithmetic says adding the same number, so I'm thinking it's arithmetic. And now I just have to figure out the next 3 numbers. So I add 7 to 28, and I get 35. And then I get 42 because I'm adding 7 to 35. And then I get 49. Pretty simple, right? You've been dealing with arithmetic and geometric patterns for quite some time. So let's get into a harder one. Let's try number 2. All right, so number 2, let's try 2, 4, 8, 16, comma, and then our additional dots. 3 things I'm going to ask for you. I'm going to ask, what's the pattern? I'm going to ask you to tell me what kind of sequence it is. And then I'm going to have you tell me the next 3 numbers. All right, taking a look at these numbers. The numbers are getting bigger, right? So, okay, I'm going to add or I'm going to multiply. All right, what should we try? Adding? Let's try adding. All right, so 2 plus what number is 4? 2 plus 2, got it. All right, 2 plus 2 is 4, so I'm going to add 2 to 4. 4 plus 2 is 6, not 8. Okay, not right. Let's try multiplying. 2 times what number is 4? 2 times 2. Try to the next one. 4 times 2 is 8. Okay, 8 times 2 is 16. Found my pattern. So we are multiplying by 2. My pattern, definition's right there. It's got to be geometric. And then obviously I just need to multiply and figure out the next one. So 16 times 2, I already did the work, is 32. 32 times 2 is 64. And 64 times 2 is 128. So far, so good, right? Good. All right, number 3. Here we go. And some of you are saying, well, Mrs. Deek, why are we figuring out these patterns? Don't wait. It's coming. It's coming. Don't worry. All right, so I'm going to throw some decimals in there. Let's try it. 4 and 5/10. 4. 3 and 5/10. 3. And then I'm not really sure what the next 3 are. 3 things. Pattern. Sequence. And next 3. I'm getting lazy. I'm just writing next 3. All right, so my pattern. 4 and 5/10, 4, 3 and 5/10, 3. My numbers are getting smaller. All right, so I know I'm not adding or multiplying, so now I got to figure out my subtracting. All right, well, I could be. All right, so the difference between 4 and 5/10 and 4 is 5/10. All right, from 4 and 3/5 is 5/10, and from 3 and 5/10 to 3 is 5/10. So the pattern is definitely subtracting 5/10 from each one. What kind of sequence? Look up at my definitions. I see that this is an arithmetic. And then my next 3 numbers, I'm just going to subtract the 5/10. So take away, and I get 2 and 5/10. I get 2 and 1 and 5/10. All right, patterns. Tell me what the pattern is. Tell me what the sequence is. Tell me the next 3 numbers. Why is this important? We're talking about function rules, Mrs. Deek, and all you're doing is giving us a list of numbers. Well, here is your answer. Number 4. All right, so we're going to make another table, a little bit different. It's going to look like this. All right, and there's only going to be 2 columns or 2 rows, and they're going to give you this thing called position, and then value of term. I would like you to start putting X and Y. Should sound familiar. Yesterday. Right, so they're going to give you a bunch of numbers. They're going to say, all right, position 1, the value is 3. Position 2, the value is 6. Position 3, the value is 9. Hopefully you're seeing a pattern. Position 4, the pattern is 12. They want you to figure out what's the rule. Now, some of you are really easily going to be like, all right, the rule is this, and you're going to be able to say it. And actually, I'm going to draw another one here. Sometimes they're going to tell you the letter N, which I'll help you figure it out. Some of us, however, cannot look at it this way, and we might need to make that table that we made yesterday. So that's what I have to do, because as the patterns get harder, I can't see it, because sometimes there's multi-step, like the 2x minus 1, and I can't look at it and figure this out. So what I'd like you to get into a habit of is, is doing this. So we would just call this the position, and this the value. Ooh, my handwriting is getting worse. Okay. All right, so my position, I've got 1, 2, 3, 4, and then I've got this N, because that's my unknown. Over here I have 3, 6, 9, 12, and I'm trying to figure out this number, like what would that be? Okay, so now I'm just going to look. To get from 1 to get to 3, 2 ways. I'm getting bigger, right? I can add. 1 plus 2 is 3. Sure, let's try that. 2 plus 2 is not it. All right, so to get from 1 to 3, I'm try multiplying. Let's try multiplying by 3. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4. Okay, we got it. The rule is multiplying by 3. And I'm just proving y. And then notice how I put this at the bottom. N times 3. I know, sorry, that's really low. N times 3, because sometimes they're going to give us the variable of n, and we're just going to use whatever variable they give us. So my rule is some variable. In this case, they're telling us n times 3, or we could write it as 3n, whatever you're more comfortable with. And then sometimes they're just going to ask you to tell them what's the, I don't know, 10th number. Sure. So what would be the 10th number? So if I tell you what the number is, you just say 10 times 3 is 30. So you'd have two answers. You'd have your rule of n times 3 or 3n, and then the 10th term would be 30. All right, we're trying another one. So I'm going to make a new table. You make one. And again, these lessons are all about finding patterns. So we're looking for those arithmetic patterns and the geometric patterns. So let's try number 5. And I hopefully this time won't go below the page where you can't see it. All right, so here's my position. I'm just going to even shorten it up a little bit and just say value. So you can see that. All right, so position 2 is worth 12. Position 3 is 18. Position 4 is 24. Position 5 is 30. And then we're going to have some unknown that we do not know. Okay, so you're hopefully looking for a pattern. If you can see it this way, awesome, great. You're that kind of thinker. I'm not. So I'm going to go ahead and make my table. All right, so I know this is my position, and this is my value, and I've got 2 and 12 and 3 and 18 and 4 and 24. Oh my goodness, my handwriting is getting worse as I go on. Okay, and then n and then some unknown. All right, numbers are obviously going up again. All right, I can add 2 plus 10 is 12, 3 plus 10 is not 18. Not going to happen. 2 times what number is 12? 6. So 2 times 6 is 12. 3 times 6 is 18. Got it. All right. My rule is multiplying by 3, right? So again, I'm going to, if I chose to do it this way, I'm just going to prove, no, I wrote 3 and I said 6. See how it's going? 6. 2 times 6. 3 times 6. 4 times 6. 5 times 6, and n times 6. So again, my rule is n times 6, or 6n, and the 8th term. So I would just multiply 8 times 6 and get 48. All right, so those are some of our function tables. I don't think I need to do another one. Hopefully I don't. But we'll definitely go slow, think about it, look for patterns. All right? Work hard, think hard.